Most Toyota hybrid owners are draining their high-voltage traction battery up to 3 times faster every single summer, and they have no idea it's happening. It's not a defect. It's not a recall. It's one air conditioning setting that forces the electric compressor to work so hard that the hybrid battery cycles relentlessly. The gasoline engine fires up far more than it should, and fuel economy drops by double digits. Real thermal data from laboratory testing on a Toyota Prius plug-in hybrid confirms it. The wrong ventilation mode increases air conditioning power consumption by over 6% of total vehicle energy, and in extreme heat, that number climbs even higher. The worst part is that Toyota actually built in a smarter system, but almost nobody uses it because nobody knows it exists. In this video, I'm going to walk you through exactly which setting is doing the damage, what the thermal data actually proves, and how to fix it in under 5 seconds. Let's get into it. The setting that causes all the damage is the fresh air intake mode on your Toyota hybrid's climate control system. That small button on your dashboard, the one with the icon showing an arrow coming into the car from outside, controls whether your air conditioning system pulls in hot outside air or recirculates the already cooled air inside the cabin. Most drivers press it without thinking. Some leave it on fresh air permanently because they believe it is healthier or more comfortable. But on a Toyota hybrid, fresh air mode is the single most energy-destructive air conditioning setting you can choose, and it directly accelerates hybrid battery drain in a way that most owners never connect to their falling fuel economy numbers. Here is why it matters more on a hybrid than on any conventional car. In a traditional gasoline vehicle, the air conditioning compressor is belt-driven. It runs off the engine mechanically, so the energy cost is somewhat hidden inside the overall engine load. You feel it as slightly sluggish acceleration or a small dip in miles per gallon, but the engine is already running anyway. On a Toyota hybrid, the air conditioning compressor is completely different. It is an electric scroll compressor powered directly by the high-voltage traction battery, the same nickel metal hydride or lithium-ion pack that drives the electric motor and powers the entire hybrid drivetrain. Every watt that compressor consumes comes straight out of the battery that is also responsible for moving the car. When you force that compressor to work harder than necessary, the battery drains faster. When the battery drains faster, the gasoline engine has to fire up sooner and run longer to recharge it. That means more fuel burned, more engine run time, more wear, and a hybrid system that is constantly cycling between charge and discharge instead of gliding efficiently the way Toyota designed it. Now let's look at what the thermal data actually shows. A peer-reviewed study conducted on a Toyota Prius plug-in hybrid electric vehicle tested 3 different cabin air ventilation modes under controlled laboratory and on-road conditions. The 3 modes were fresh air, with air conditioning on, recirculated air with air conditioning on, and fresh air with air conditioning off. Researchers used the Supplemental Federal Test Procedure SC03 driving cycle, which is specifically designed to simulate real-world driving with air conditioning active. The results were striking. When the air conditioning was set to fresh air mode, the compressor consumed approximately 34.5% of total vehicle power. When switched to recirculation mode, that number dropped to 28.4%. That is a 6.1% reduction in total power consumption just from changing one setting on the dashboard. On a hybrid, that 6.1% is not abstract. It translates directly into how fast the traction battery depletes, how often the gasoline engine must engage, and how many charge-discharge cycles the battery pack endures over its lifetime. To put that in real driving terms, imagine sitting at a red light on a 95-degree day. Your Toyota hybrid is in electric vehicle mode. The engine is off and the cabin is cooling. In recirculation mode, the air conditioning compressor is working with air that is already at or near your target temperature. It spins slowly, draws modest power, and the battery holds steady. In fresh air mode, the system is pulling in 95-degree air from outside, running it across the evaporator core, and trying to cool it down to your set temperature from scratch, over and over again. The compressor spins harder, draws significantly more current from the high-voltage battery, and the battery state of charge drops noticeably faster. Within minutes, the hybrid ECU detects the falling charge level and fires the gasoline engine to compensate. That engine run was entirely avoidable. Multiply that by every stoplight, every parking lot wait, every drive-through line across an entire summer, and you begin to understand the cumulative cost. The U.S. Department of Energy has stated clearly that under very hot conditions, air conditioning use can reduce a conventional vehicle's fuel economy by more than 25%, and that the effect on hybrids, plug-in hybrids, and electric vehicles can be even larger on a percentage basis. That last part is critical. Because the hybrid's electric air conditioning compressor draws from the traction battery rather than the engine belt, the energy penalty is magnified in ways that most drivers never realize. Independent automotive data supports this as well, showing that hybrid vehicles can experience up to 9.3% more fuel consumption in city driving and 2.8% more on highways when running air conditioning at full load. City driving is where it hurts the most, because that's where the hybrid system relies most heavily on electric power. Every unnecessary watt consumed by the air conditioning compressor is a watt stolen from the electric motor that would otherwise move the car without burning a drop of gasoline. If you made it this far, then consider liking this video, giving it a thumbs up, and subscribing to my channel. This helps me bring you more honest car advice. Now here is where it gets even more interesting. Toyota actually designed the hybrid climate control system to default to recirculation mode when the power button is turned on. On many Toyota hybrids, including the Camry Hybrid, RAV4 Hybrid, Corolla Hybrid, and Prius, the system automatically selects recirculated air as the starting mode. Toyota's own documentation states that when the outside temperature exceeds 75 degrees Fahrenheit and the air conditioning system is active, the system may automatically switch to recirculated air mode specifically to reduce air conditioning power consumption and fuel consumption. Toyota engineers clearly understood the energy math. They built the system to protect itself. The problem is that millions of drivers override this default every single day without understanding what they are doing. They press the fresh air button because they want ventilation, because they are worried about air quality, or simply because they do not know the difference. Every press of that button undoes the engineering Toyota spent years perfecting. But the damage from fresh air mode goes beyond just fuel economy. Every additional charge-discharge cycle the hybrid battery experiences shortens its overall service life. Toyota hybrid batteries are designed to operate within a narrow state of charge window, typically between 40% and 80%. The hybrid electronic control unit carefully manages this window to maximize longevity. When the air conditioning compressor draws excessive power, the battery drops toward the lower boundary faster, forcing the engine to kick in and push the charge back up. That is a full cycle. Over thousands of hours of driving in summer heat with the wrong air conditioning setting, those extra cycles accumulate. Battery degradation is cumulative and irreversible. A battery that cycles 3 times more often in summer is aging 3 times faster during those months. You won't feel it this year or even next year, but by the 7th or 8th year, when the battery is approaching the end of its designed life, those extra cycles will be the difference between a battery that still holds strong and one that needs a $2,000 to $4,000 replacement. Now let's talk about what Toyota built into the system that most owners completely ignore. Many Toyota hybrid models include a feature called S-Flow, which stands for Smart Flow. This system uses occupancy detection to determine which seats are occupied and directs air conditioning only to those zones. If you are driving alone, S-Flow reduces or shuts off airflow to the passenger seat and the entire rear cabin. This dramatically reduces the thermal load on the electric compressor, which means less power drawn from the traction battery, fewer engine start cycles, and better overall fuel economy. Toyota filed for and received EPA greenhouse gas credits for this technology, which tells you exactly how significant the energy savings are. The full S-Flow system earned a 3.3 grams per mile carbon dioxide credit from the EPA, which may sound small, but represents a meaningful reduction in real-world energy consumption across millions of vehicles. Real-world owner data from RAV4 hybrid drivers suggests S-Flow combined with Eco Mode can save 2 to 4 miles per gallon on common trips in 90-degree heat. That is not a marketing claim. That is real fuel saved by letting the system manage airflow intelligently instead of blasting cold air into empty seats. Yet many drivers disable S-Flow because they notice reduced airflow and assume something is wrong with the system. It is not broken. It is protecting the battery. There is another layer to this that most drivers miss entirely. Toyota's Eco Mode does more than just soften throttle response. It also modifies how the climate control system operates. When Eco Mode is active, the air conditioning electronic control unit adjusts the target cabin temperature to a minimum of 77 degrees Fahrenheit, regardless of what the driver sets on the dial. If you set the thermostat to 64 degrees Fahrenheit, but Eco Mode is engaged, the system will maintain 77 degrees Fahrenheit as a floor to limit compressor power draw. This behavior confuses many owners who feel the air conditioning is not working properly. Some disable Eco Mode entirely, which removes the fuel-saving throttle mapping and the air conditioning power management simultaneously. Others crank the temperature dial even lower, which accomplishes nothing in Eco Mode but would cause the compressor to run at maximum capacity if Eco Mode were turned off. Toyota designed these systems to work together. Eco Mode, recirculation, and S-Flow form a complete energy management strategy for the climate control system. Using them together is how Toyota engineers intended the car to be driven in hot weather. Disabling any one of them increases battery drain, engine runtime, and fuel consumption. The electric compressor in Toyota hybrids operates on the full voltage of the high-voltage traction battery, typically around 200 to 250 volts depending on the model and battery state of charge. It is a variable speed unit, meaning the hybrid electronic control unit can spin it fast or slow depending on cooling demand. The air conditioning electronic control unit calculates the target compressor speed using inputs from the cabin temperature sensor, the outside temperature sensor, the solar radiation sensor mounted on the dashboard, the evaporator temperature sensor, and even the humidity sensor in models equipped with one. When humidity is lower, the compressor can spin slower, reducing electrical demand while still maintaining comfort. This is an incredibly sophisticated system, and it works beautifully when the inputs are reasonable. But when you override the ventilation setting to fresh air mode in extreme heat, You are feeding 95 to 110 degrees Fahrenheit air directly into that system and forcing every one of those sensors to demand maximum compressor output. The compressor spins at its highest speed, draws maximum current, and the traction battery pays the price. There is a simple habit that protects everything. When you get into your Toyota hybrid on a hot day, roll the windows down for 30 to 60 seconds before driving. This vents the superheated cabin air, which can reach 140 to 170 degrees after sitting in direct sunlight. Then close the windows. Make sure the climate control is set to recirculation mode. Set a reasonable temperature like 72 to 74 degrees and let the system do its job. The compressor will cool the cabin quickly because it is recirculating air that is already dropping in temperature with each pass through the evaporator. Within a few minutes, the cabin is comfortable. The compressor slows down and the traction battery barely notices the load. If you need fresh air for ventilation, switch to outside air briefly every 15 to 20 minutes, then return to recirculation. This prevents the cabin from becoming stuffy while keeping the compressor load manageable. That simple routine, vent first, then recirculate, can cut your air conditioning related battery drain by 30 to 40% compared to running fresh air mode continuously. One more thing most Toyota hybrid owners never consider. When you idle in your hybrid with the air conditioning on and the shifter in park or drive, the system works exactly as designed. The electric compressor runs off the traction battery, the engine cycles on briefly to recharge when needed, and everything stays balanced. But if you accidentally leave the shifter in neutral, the hybrid system cannot charge the traction battery even when the engine runs. The battery depletes steadily, the engine runs more and more frequently, and the entire energy management system breaks down. Toyota designed the hybrid charging logic to function in park and drive only. Neutral disables regenerative charging entirely. Sitting in neutral with the air conditioning blasting on a hot day is one of the fastest ways to drain a Toyota hybrid battery to dangerously low levels. It is a mistake that happens more often than people think, especially at car washes or during roadside stops where drivers shift to neutral out of habit. The bottom line is simple. Toyota built one of the most intelligent climate control systems in any production vehicle. The electric compressor, the variable speed control, the S-Flow occupancy detection, the Eco Mode air conditioning management, and the automatic recirculation logic all work together to keep you cool while protecting the hybrid battery from unnecessary stress. But all of that engineering gets defeated the moment you override the system with fresh air mode and a 64-degree temperature setting on a 100-degree day. The thermal data is clear. Fresh air mode increases air conditioning power consumption by over 6% of total vehicle power compared to recirculation. Over a full summer of driving, that translates into thousands of extra battery cycles, hundreds of unnecessary engine starts, and measurable degradation of the most expensive component in your hybrid system. A 5-second button press is all it takes to prevent it. Use recirculation. Trust the system Toyota built, and let your hybrid battery last the way it was designed to. If you are enjoying this video, consider watching this one, where I am sharing habits that make your Toyota hybrid cross even 300,000 miles.